Hello, people. Hello, everyone. Whoever is watching this live, welcome to Letstute. For people who haven't subscribed to our channel, do subscribe. Okay, let me just quickly introduce myself. My name is Sanjana Das, and okay, so I am a science teacher. I'm a physics teacher, and here we are at Letstute. Letstute, where we provide you a lot of courses in science in our website. The name of the website is www.letstute.com. So do subscribe it. Okay. Also, guys, don't forget to press the bell icon to never miss an update from us. Okay. Also, we have a lot of courses. We have a lot of courses. The chapter that we have done already, it is this chapter. We have a lot of videos based on this chapter, that is the motion chapter. Before that, hi, hi James Anthony, how are you? Okay. Hi James. Hi everyone who's watching this video. If you have missed the introduction, yeah. Okay. So you know me, Sanjana. Yeah, we are doing a course, or we are doing some numerics on motion chapter, and these numerics, let me tell you, see, there are people who will have speed, velocity, distance, displacement, but we are trying to cover something which is slightly difficult, and that is graphical numericals. It's very difficult. It's very difficult. So if you have any other hi Armohan, hi Prakash, how are you? Okay, so yeah, I'm doing good, James. I'm doing good. So, guys, motion. See, there was some basic. Last lecture we had some basic numerics based on speed, velocity, distance, displacement. Do check that out if you want some easy numerics which come in your exams. But sometimes, okay, sometimes there are some numerics which are actually slightly confusing, and those numerics are your gravitational sorry, your graphical numericals. So your graphical numericals and your kinematical equations, my god, whoever knows those three kinematical equations. Now, before starting, if you know those three kinematical equations, just quickly put it in the chat box, because we are going to use those three kinematical equations. Yes, we are going to do those three kinematical equations. We are going to do numerics based on that. So that is one difficult part that we are trying to crack. The second difficult part that we are trying to crack is the graphical questions. It's very difficult to crack the graphical questions, because the data that is being provided, it's not a given data that you can put it in a formula. It's rather a pictorial data that it's given in a graph, and the graph is so difficult to understand. It's so difficult. What they would do is they would just give you random graphs. Okay, they'll just give you random, yeah, they'll just give you as a random figures, and based on that figure, you have to tell what happens to the velocity, what happens to see, there's a random figure going on. Okay, hi Rucha, how are you? Okay, we are trying to cover graphs. They'll just give you some random figures and tell you, acha, tell us whose velocity is greater, who's moving with a faster velocity, who covered more distance. It's so difficult to just look into a picture and determine that, okay, whose velocity is greater. So, what we are going to do is we are going to cover the topic. We are going to cover the topic graphical questions. Now, in graphical questions, one topic okay, so in graphical questions, there are two or three things that you should know. You should know what's a distance time graph. You should know what's a velocity time graph. You should know after distance time graph. Yeah, so you should know what's a distance time graph or a displacement. So these type of graphs, distance and displacement time graph can come. There can be velocity time graph. They can ask you velocity time graph or speed time graph, and they can ask you acceleration time graph. Now you're lucky, because those people don't ask you acceleration time graph that much. Distance time graph and velocity time graph, they'll ask you a lot of questions. Yes. Distance time graph and velocity time graph, they will ask you a lot of questions, but then acceleration time graph is slightly, acceleration is slightly something which they don't ask you. Now, in distance time graph, there are some things that you should know. For that, for a distance time graph, what do you mean by a distance time graph? Whenever we are doing a graph, always remember there are two axes. Everyone who's done a graph, they know there are two axes. There's a x-axis and there's a y-axis. So the x-axis always shows the independent variable. If it is an x-axis, it will have an independent variable. Yes. So think about it. Come on, Rucha, James, R. Mohan. Think about it. Hi, Rushikesh. How are you? So think about it, guys. In a in a graph, there's a dependent variable. There's an independent variable. Dependent variable, matlab something which depends on the other one. Independent, matlab it doesn't depend on anything. It will just go on its own. So if you have distance, and if you have time, who's the who's the dependent variable and who's the independent variable? Think about it. Distance and time. You have distance and you have time. Tell me who will be the dependent variable, who will be the independent variable. I'll tell you what do you mean by dependent. Yeah, thank you, Rishikesh. Okay, think about it. Distance and displacement. These are some of the questions that you should know. Why it comes in x-axis, why it comes in y-axis. If it is distance and time, I'll frame it to you in this way. Distance and displacement. Tell me distance and time. Who depends on whom? If I'm changing the distance, will the time change? If I'm changing the distance, will the time change? Okay. But if I'm changing the time, will the distance change? Yes. Remember that even if you're not moving a body, if there is a body here, I'm not moving the body. The body is at rest. Doesn't matter. The time keeps on increasing. That is, there is a saying, time doesn't wait for anyone. It's true. Time doesn't wait for anyone because time is an independent variable. Doesn't matter the velocity is changing, doesn't matter if the acceleration is changing, doesn't matter if the distance is changing, time will keep on changing, time will keep on increasing. So therefore, always remember, yes guys, always remember whenever you're doing a graph, time will be in the x-axis. If you're making the x-axis will be time, and whatever is remaining, that would be in the y-axis. Always remember it. Whenever you're drawing a graph, the biggest mistakes that I've seen a lot of students do is that they do the distance time graph, and what they'll do is they'll put the time in the y-axis and distance in the x-axis. Don't do that. Now, after that, based on the different types of graphs, we have distance time graph, velocity time graph, and acceleration. Acceleration we will not do. Will not do acceleration because acceleration time graph doesn't come in your portion. Acceleration time graph is not there in your portion. What's there is just distance time graph and velocity time graph. Okay. Yes. Guys, please do check out our courses on in math and science, but in science in our website www.letstute.com. So in distance time graph, remember there are three instances. First, what happens if the body is not moving? Guys, think about it. If the body is not moving, will it change its distance with respect to the origin or with respect to a point? The body is not moving. I repeat, distance time graph for a body at rest. How will it look like? If the body is at rest, how will the graph look like? Remember, the body is not changing its position. The body is not changing its distance from the origin. If it is at rest, how will that graph look like? The distance time graph for a body at rest. If you all want, you all can tell me in the chat section. By that time, I'll just tell you how it looks like. I'm going to use a different color pen. Let's use a blue color pen. See, if a body is at rest, it means it's not changing its position. So after 1 second, it will be in the same position. After 2 seconds, it will be in the same position. After 3 seconds, it will be in the same position. After 4 seconds, still it will be in the same position. That is, the body is not changing its position with respect to time. So though the time is increasing, the body is not changing its position. So if you want to choose, guys, if you want to choose, okay, you're not understanding. Okay. No, Rishikesh, it's not blank. Rather, it would be a horizontal line. Hi, Discoverer. Welcome to Letstute. I'll just quickly tell you what we were covering so you'll understand. We are covering a topic in motion chapter. The chapter is motion. It's a 9th standard chapter. In that chapter, yes, yes. In that chapter, in motion chapter, we are covering a difficult concept, that is graphical concept, which there a lot of people don't cover, and it comes in your exams. They'll give you a picture and they'll tell you explain. So if they are giving you a picture and they are telling you explain, you have to look into the graph, analyze the graph, understand the graph, and then answer it. Yes. Hi, Atithya. How are you? So you have to analyze the graph, look into it, and you should know what those things are. Otherwise, you won't be able to analyze it, because these are some of the marks which students easily give up. We don't want the students to give up. All the board, this is a question which is common which students give up. This is one question where even in your higher grades, when it comes, you all give up the marks. Don't give it up. Understand what the question is. Distance time graph is the graph between the distance covered by a body with respect to time. For example, if I'm covering 5 meter in 10 seconds, then next 5 meter. Okay, see, if I'm trying to plot a graph, if there is a body, okay, if there's a body, first the body covers 2 meter in 10 seconds. Then the body covers, okay, then the body covers 4 meter in 20 seconds. Then the body covers 6 meters in 30 seconds. Then the body covers 8 meters in 40 seconds. Guys, can you tell me how much distance will it cover in 50 seconds? How much distance will it cover in 50 seconds? Guys, how much distance will the body cover in 50 seconds? See, if you look at the numbers, you will see that the body, okay, that the body is increasing its distance. As the time is increasing, the body is going away, away, away. So first 10 seconds, it covered a distance of 2 meter. Next 10 seconds, that is within 20 seconds, it covered a distance of 4 meter. Then next 30 seconds, it covered a distance of 6 meter. Okay, okay. 8. Rishikesh, your for 8, 40 seconds is absolutely correct, but I'm saying what distance will it cover in 50 seconds? What distance will it cover in 50 seconds? I want to solve. I've seen the questions and wanted to ask the best approach to solve it. We are going to have the best approach. For that, you should know high discovery. You have to know the basics. So this is the basic. What happens if the body is in a uniform motion? If the body is in a uniform motion, it covers equal distances and equal interval of time. See, it's covering 2 meter in 10 seconds. Then once again, it's covering 2 meter in 10 seconds. Then 2 meter in 10 seconds. This means the body will cover 10 meter in 50 seconds. So if I'm trying to plot a graph, okay, if I'm trying to plot a graph of uniform motion, in uniform motion, this thing is called as uniform motion, guys. And if I want to plot a distance time graph of uniform motion, see, this is what I have to do. For a body in uniform motion, remember, let's plot it like this. Wait, 10, 20, 30, 40, and last 50. And this is 2, 4, 6, 8, 10. Now, guys, this is important. Look carefully. Yes. Very good, discoverer. Very good. You are right. It is an oblique cloud. Yes, it is an oblique one. Straight line, uniform motion. Very good. It is, yes, yeah, it is the oblique graph. Now, remember why I'm getting an oblique graph for a uniform motion. For a uniform motion, if you look at the data, as you're increasing, see if I want to plot the data when distance covered is 2 minutes for time 10 seconds. So what you have to do is you have to say, acha, for 10 seconds, the distance covered is 2 meters. So this is the distance covered. Then for 20 seconds, it covered 4 meters. So 20 seconds it's covering 4 meters. The 20 seconds, it's covering 4 meters. See, for 30 seconds, it's covering 6 meters. So for 30 seconds, I'm getting 6 meters. So you're right. You're right. Come on, Rishikesh, guess this graph. What kind of graph do we call it? For 40 seconds, we are getting 8 meters. What is this kind of graph called as? For 50 seconds, we are getting it as 10 meters. This is a uniform motion graph. How do you know it's a uniform motion? I can predict what happens next. I know it will go 12 meters in 60 seconds. This kind of graph. Okay, distance time graph and velocity time graph. Yes, Deepak, I will teach it. Yeah. I've just started it, and yeah, I will teach you. So yeah, Rishikesh, think about it. It is a uniform motion. Yeah, coordinate system. So, but then when you're actually drawing the graph, Deepak, I am teaching the distance time graph. When you're drawing a graph and when you join the line, what you get is a linear graph. This means the body is covering equal distance in equal interval of time. That's called as uniform motion. Now, what happens if the body does not cover equal distance in equal interval of time? Think about it. See, if it is at rest, okay, we just did one graph initially. What happens if the body is at rest? If the body is at rest, I am going to get this graph. See, if the body is at rest, I'm going to get a graph like this. Why? Because the body is not changing its position. If a body is in uniform motion, okay, if it is in uniform motion, the graph that I'm getting is a linear graph or an oblique graph, as discoverer said. But always remember, third point, what if the body is in a non-uniform motion? What if the body is a non-uniform motion? What if the body is covering unequal distances in equal interval of time? Yes. What happens if the body? Yes. Coordinate geometry graph. Yes. Deepak, please press the bell icon and you will get the previous videos. And what happens if it's a non-uniform motion graph? Think about it. For a uniform motion, you're getting a linear line. Once again, think about it. For a uniform motion, you're getting a linear line, a straight line. What will it be for a non-uniform motion? Okay, I'll give you the hint. For a non-uniform motion, what does that mean? That means the body is not covering equal distance in equal interval of time. And because the body is not covering equal distance in equal interval of time, this is how the graph will look like. The graph will look like this. It is not a straight line. It is a curved line. Remember, the distance time graph for a body in non-uniform motion is a curved line. I would want you all to remember all the three because it can come in your exams. So when a body is in a non-uniform motion, yes, a zigzag line. Very good. Very good, Deepak. Thank you so much for clicking on the bell icon. Everyone, please click on the bell icon to never miss an update from us. Okay, yeah, very good, Mohan. It is a curve. Now let's go to after this, let's go to one important graph. What happens is your teachers are going to ask you one more question. It comes a lot. That is, how do you find out the velocity in a displacement time graph? If it is a displacement time graph and if you want to find out the velocity, you're going to take a slope. Slope is y2 minus y1 upon x2 minus x1. This is called as the slope. If you have a distance time graph and if you want to find out the speed from a distance time graph, if you want to find out the speed, yes, yes, it's a curve. Now, if you have a distance time graph, what are you asking? Okay, Discoverer is asking for that we use at times the differential calculus or integration. We are going to differentiate it actually. Yeah, we are just differentiating it, but not those difficult questions. We'll go in a very easy manner. We'll say we are finding slope. Yes, slope form. Now in slope form, think about it. Y2 minus y1 upon x2 minus x1. Let's do it for this graph. For this graph, if I want to find out the slope, see, if I'm taking velocity at what point, they'll give you any 2 points. Your question paper may you'll get 2 points. Let's say I take from 20 seconds to 40 seconds. I have to find out the speed of a graph from 20 second to 40 second. So I'll try to find out what is y2. I'll try to find out what is y1. I'll try to find out what is x2 and what is x1. First, let's take y2. y2 के लिए check what is y2. y2 is 8. So I'll just write 8 here. I'll just write 8 here. Okay, I'll just write 8. What is y1? Look at y1. Look at y1. Guys, what is y1? Think about it. What is y1? Meaning of slope. Okay, Deepak, what is the meaning of slope? So by the time, guys, I'm explaining, Deepak, what is the meaning of slope, I want y'all to just go through. I want y'all to go through and tell me what will be the value of x2 and x1. I'm going to teach Deepak what do you mean by slope. But by the time I'm doing that, I want others to comment and tell me what's the value of x2 and x1. Come on, the graph is there in front of you. Try to find out the value of x2 and x1 and don't mix it up. And for Deepak, slope, in layman's term, what do you mean by slope? In layman's term, hi Harsh. So in layman's term, if there's any body, okay. Yes, Mohan, you're almost correct. We are going to figure that out. But for people who don't know what is slope, layman's term, what do you think slope is? Slope is a slope. That's what is slope, Deepak. For everyone who doesn't know what is slope, slope is this. It's there in your math, it's there in your science. Slope means this slope. If the slope is less, yes, the slant. If the slant is less, then the slope is less. If the slant is more, then the slope is more. As simple as that. So, yes. So, Deepak, slope determines, yeah. So, if the slant is more, this means the speed is more. If the slant is less, then the speed is less. That's it. Slope is used to determine different quantities based on what graph are we taking. Here we have a distance time graph. Because we have a distance time graph, when we take that slant or when we take that slope, it means we are trying to take the speed. If I have a velocity time graph and if I take a slope, then I'm trying to find out what is the acceleration, how much is the change. So slope is y2 minus y1 upon x2 minus x1. So some people have answered me, it is 40 minus 20, that is equal to 4 upon 20. Very good. That is equal to okay, so we are getting 4 divided by 20 and 4 divided by 20 is equal to 0.2. So therefore, the velocity of the body is 0.2 meter per second. Are you all getting the same value, guys? You just have to do 4 by 20. 4 by 20 is into 1 is equal to 20. Okay, no, 4 by 20. Slope is measured mainly in degrees. Yeah, but no. Here we are actually, the slope ka, unit would be whatever is there in the x and y axis. So here the unit of x axis is meter, of y axis is meter, and the unit of y axis is, sorry, x axis is second. So therefore here the unit of slope would be meter per second. Slope depends on what is the unit given in your graph. Acha, this was distance time graph. Okay, this was distance time graph. Now let's do velocity time graph. In velocity time graph also there are three types of graphs. First, when a body is moving with a constant velocity. If the body is moving with a constant velocity, guys, is it changing its velocity? Think about it. If a body is moving with a constant velocity, this means the body is not changing its velocity. So if I want to find out the velocity time graph, I have given you a question. But to make you answer the question, I'm not going to answer the question for you. I'm just going to teach you how can I solve IRODOV. Okay, so no, I'm gonna give you a option. Think of the option. See, there's a velocity time graph, and for a velocity time graph, if you're trying to plot a velocity time graph, remember, okay, there are three things that you have to plot. First, when a body is moving with a uniform velocity or a constant velocity. Second, when a body is moving with a non-uniform velocity. So non-uniform mein there are two things. First, when the body is moving with a constant acceleration, that is the velocity is increasing but constantly. And third, when a body moves with like not a constant acceleration, that the velocity is changing of a body anyway. So there we have three types of graphs. First is when a body is moving with a constant velocity. Constant velocity, matlab in a layman's term, the body's velocity is not changing. Guys, for a lay. Oh, okay, okay. No. I have not heard of the name of the book IRODOV, but I will search about it, discover. Okay, I'll go through it and yeah, I'll see. So now velocity time graph mein there are three. First, when the body is moving with a constant velocity. Constant velocity as in the velocity is not changing only. So if the velocity is not changing, the value of velocity will not increase. The value of velocity will be constant. That is, you're going to get a horizontal line parallel to the x-axis. But if guys, the body is moving with a uniform acceleration, that is the velocity is increasing, but the velocity is increasing uniformly, then that kind of body is said to be having a linear graph, that is like this. Velocity time graph, guys, velocity time graph. Okay, so velocity time graph means the body is of a linear or a uniform motion, means you're going to get a linear graph. Now what does this mean? Let's say I'm trying to drive. So initially while driving, first I had a speed of 10. I was driving with a speed of 10. Then 5 minutes later, I was driving with a speed of 20 meter per second or 20 kmph. Let's take kmph. Yes. Okay, fine. Fine. Yeah, I'm talking in English only. I'm not teaching in Hindi. Don't worry, Deepak. I just teach in English only. Okay. So, velocity time graph. What happens if a body is moving with a constant acceleration? So initially if someone is driving, okay, if someone is driving, what happens is first 5 minutes mein its velocity is 10, then second 5 minutes mein its velocity is 20. So if someone asks you how much did it accelerate, it accelerated 10, it increased its velocity by 10. Acha, after 5 minutes, now its velocity is 30. After 5 minutes, now its velocity is 40. What's happening is after 5 minutes, what's happening? Its velocity is increasing. See, the body is accelerating. So after every 5 minutes, the velocity is increasing. So if I want to plot a graph, and when I plot a graph, this is what I will get. This is the graph I'll get. I'll get a linear motion if the velocity is increasing linearly. Acha, but what happens in between from 30? Now the body moves has a velocity of 50. Now the body has a velocity of 50. Acha, from 50, then it will have, let's say, a velocity of 20. Then it's having 10. My God, it's so much of a confusion. It's so much of a confusion. So here, we are not going to get a constant graph. We are going to get a zigzag line, as Rishikesh had said. We are going to get a zigzag line. Yes, we are going to get a zigzag line. So for a non-uniform motion, you're going to get a zigzag line graph. So let's try to solve the questions here. I told you I'll not help you. So just look at it. Think about it, guys. Think about it. From a given velocity time graph, okay, from a given velocity time graph, it can be inferred that the object is in dash motion. Look at it's a velocity time graph and it is a horizontal line. Tell me, will it be in a uniform motion at rest, non-uniform motion, or moving with a uniform acceleration? Think about it, guys. Come on, think about it. Look at the question. From the given velocity time graph, it can be inferred that the object is in. It's a velocity time graph. What do you think would be the answer? Is the body in uniform motion? Is the body at rest? Is the body in non-uniform motion? Think about it. Well, the body is at uniform motion. Why uniform motion? The body is at uniform motion because look at the velocity. The velocity is not changing. That is, the body is covering equal distance in equal interval of time. So the answer is A. The answer is A. Because for a body moving with constant velocity, you're going to get a flat graph parallel to the x-axis. Now let's complicate it a lot. Now they've given you a speed time graph, but they've told you to find out the distance. Remember, for a speed time graph, if you have to find out the distance, this means what you have to do is you have to find out area. Area of a speed time graph will give you the distance covered. They have told you to find out the distance between 30 minute and 40 minute. So 30 minute and 40 minute, the curve under 30 and 40 minute. This curve, if you find out the area, you can find out the distance covered. So tell me, what will be the area? This looks like a rectangle. See, this looks like a rectangle. What can be the area of this rectangle? Think about it. Okay, so yeah, hi Sai Shruti, hi Discoverer. Okay, Malika is giving us the answer. Malika is saying it's 15 into 10. Let's see if it is 15 into 10. If you want to find out the area, this acts like a rectangle. If it is acting like a rectangle, the length is 15. The breadth, look at the breadth. Breadth is this distance. That is 40 minus 30. So 40 minus 30 is 10. And this is 15. Malika, you are absolutely correct. Malika, you are absolutely correct. The distance is 15 into 10. So 15 into 10, the distance covered will be 150. How did I get it as 150 kilometer? I got it as 150 kilometer because it was 15 into 10. Then they've told us distance between 10 minute and 40 minute. See, now Malika has given us the answer for 30 to 40. Who can give us the answer for 10 to 40? Come on, 10 to 40. 10 to 40. Think about it. Here's 10. Here's 40. Look at it. Here's 10. Here's 40. What would be the answer? Yes, breadth into length. Length into breadth. Come on, think about it, guys. What is the breadth? What is the length? See, now for the second one, they've said from 10 minute to 40 minute. So 10 minute to 40 minute, look carefully. What will it be? 10 minute to 40 minute. It is from 10 to 40. You know the formula, it is length into breadth. So if it is length into breadth, okay, if it is length into breadth, this means I have to do this. Come on, who's going to give me the answer? I want the proper answer. Come on. Come on, guys. It is 30 into 15. Very good, Malika. Very good, Deepak. Okay, Rishikesh gave me the answer as 20. Rishikesh, I don't think so it's 20. It is actually 30 into 15. It is 30 into 15, guys. For the second one, the distance is 30 into 15. So for the second one, for answer B, it is 30 into 15. Come on. Let's see who gets it right. What is 30 into 15? Come on. 30 into 15. We are getting the answer as 450. So it is going to cover a distance of 450 kilometer. Yes, it is 450 kilometer. Okay, now last, what is the speed of the particle? Now this is the easiest question if you know how to read a graph. If you know how to read a graph, this is like the easiest question. What is the speed? What is the speed of the particle? It's like the easiest question. Yes, very good, guys. Very good, Deepak. Very good, Mohan. Very good, teens. You are absolutely correct. The answer is 450. Okay, guys, think about it. What's the speed of the particle? Look into the graph. They have told you what the value is. If you directly look into the graph, yes, teens, you're actually correct. Okay, teens bestie. Teens bestie, you're absolutely correct. Yes, Deepak, you're absolutely correct. The answer is 15 kmph. Proud of you guys. Now let's go to the next question. For the next question, they have told you, now they have complicated it a little. Now they've given you a distance time graph, but they've not given you a straight graph. Now the graph that they've given you is the oblique graph or a linear graph. Now if you want to find out the area, it will just not be length and breadth. Yes, it will just not be length and breadth. Okay, hi Amber. Yeah, teens bestie, I'm going to call you Amber. So find the distance covered by a particle during the time interval from 0 to 4 seconds. Now the thing is, this is not a straight graph. So your length into breadth is not going to work here. They've told you to find out the distance from 0 to 4 seconds. That is still here. So to 0 to 4 second, from 0 to 4 second, you have to find out the area of this triangle. Does anyone remember what's the area of a triangle? What's the formula for area of a triangle? Think about it, guys. If you figure out, yes, if you figure out the area of a triangle, this sum is done for you. You will be able to crack this sum if you know the formula for area of a triangle. I'm going to help you, but I'm going to help you 1 or 2 seconds. Yeah, half into base into height. Amber, you are absolutely correct. Come on, Rishikesh. Come on, Deepak. Buck up. Yes. Raja Guru, you're actually correct. The answer is, both of you are correct. The answer is half into base into height. So come on, help me. It's half into base into height. That is half into the base is, let's look at the base. The base is from 0 to 4. That is, the base is 4 into height. Look at the height. The height is 20. So I'm just going to substitute 20. Now when I substitute that, 2 ones are, 2 tens are. Whoever knows the answer can comment it. Come on. And 4 tens are 40. This means that the distance covered by the body in 4 seconds is 40 meters. That's it. Very good, guys. Very good. Okay, half the hypotenuse and side. Yeah, that's not actually rather than saying hypotenuse, because you cannot find the value of hypotenuse, Amber. Remember, we don't have the hypotenuse value and we are not going to go into trigonometry. So rather, we'll just simply use we are going to use the graph and directly find out the value, and the value is 40. Proud of you guys. Well, I'm running out of time. So I'm going to end this lecture. Now, before ending this lecture, I'll just quickly tell you what we covered. So we covered what happens in the motion chapter. We covered graphical questions. In graphical questions, I explained you the 3 types of graph, that is distance time graph, velocity time graph. Acceleration doesn't come in your exam, so I've not covered that. In distance time graph, we've covered how to find out the speed of a body. In velocity time graph, if you want to find out the distance traveled by a body, you are just going to take the area. But if you want to find out the acceleration of a body, it's exactly like finding the speed. That is, you have to take a slope. The moment you take a slope, you'll find out the acceleration of the body. Now, with that, I am done with the lecture. Do y'all have any doubt? It was a mistake. Don't worry, Amber. It's fine. Okay, so I'm going to end the lecture if I don't have any questions now. So you have around 1 minute. If you have any questions, just ask me anything related to physics. Anything related to physics, I will cover it. So okay, yes, Raja, I am promising you. Please tune into our channel. We'll make a video on all of these graphs. There would be a special video. There would be a special video for just these graphs on the working of these graphs. Forces and laws of motion. So I'm not going to teach forces, laws of motion, and gravitation, all three chapter in one lecture. But forces and laws of motion is a topic I will cover, Deepak. Tune into our channel. Don't forget to press the bell icon because next topic that we are going to try to cover is forces and laws of motion, the next chapter. So I'm going to try to cover that. Don't forget. And Raja Guru, I am going to make a graphical video. I'm going to make a video only on graph. Just keep tuned, keep press. Just see to it that the bell icon is pressed. So whenever we are making a video and keeping it out or bringing it out, y'all are there. So yeah, so I'm going to tell you what is our schedule. So next time we'll try to do forces and laws of motion. That's a topic I'll try to cover. After that, gravitation, and after that, I'll try for electricity. But these are basic topics that I'll cover. Also, next thing is we are also going to take out a video on graphs. Okay, Lavanya. Okay. No issues. I'm sorry, Lavanya. So already subscribed. Thank you so much, guys. It means a lot. So fine. If you don't have any questions, I'm gonna end the lecture. But before ending, just a reminder. Don't forget to press the bell icon and to visit our channel www.letstute.com. Yes. Yes. Rishikesh, it's always a pleasure when you're there in the lecture. It's so good. Yeah, Amber, thanks a lot. I'm gonna end the lecture then. Bye, guys. Take care and keep tuned. Okay, chalo. Bye.